Alright, interior angles of polygons. So let's start with these words. Polygon. Before any of you shout out 5, it's not pent, it's poly. So polygons is many straight sides, many straight edges. So this is a polygon, they're all straight. 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 Okay, now oftentimes when asked, are there shapes that aren't polygons? You've just fallen asleep. I mean, that clearly is a shape, but there are no straight edges to be found. It's not a polygon. Even a semicircle or whatever this is almost has a straight edge, but they're not all straight, so it's not a polygon. Not a polygon, not a polygon. Polygons. Okay, interior. That just means on the inside. So the interior angles of this polygon are here, here, and here. And in a triangle, you know that their total, or their sum, is 180 degrees. Triangle, 3 sides. I'll probably write that a bit clearer so we can see that for that it's 180 degrees in there. This is 4-edged, so it's a quadrilateral, and a lot of you know that those 4 angles add up to 360 degrees in total when added together. But what about this, and indeed any other polygon we happen to draw? Well, the trick is to use the one we know, the triangle. If I select an edge, well, it doesn't have to quite be this way, this is a simple way of getting it right. If I select an edge and I join it to the others, I will have some triangles. And I know that these 3 are 180 degrees in total when added together. I know that when I add these 3 together, I get 180 degrees. And I know when I add these 3 together, I get 180 degrees. So this is useful because those 2 are this corner of the pentagon. Those 2 are this vertex of the pentagon. That's already the pentagon. Those 3 are already the pentagon. So my 5 blue arcs are the same as all those little black ones. And that's 3 lots of 180, which I happen to know is 540 degrees. So if you do not know the total, you can always work it out by putting triangles into the shape. Okay, and that's just as true with this polygon here. What type is it? I haven't even counted them yet. I think it's 1, 2, 3, 4, 5, 6, 7 edges. This is a heptagon. This is a heptagon, which you might see in some pieces of work just written as a 7gon. Sometimes when people using shorthand they use that. So what's the sum of the angles inside this? Well, we'll do the same triangle trick. And in fact, you don't even have to do it from the same vertex. As long as they don't cross each other, this will work. So as long as my edges that I draw inside the shape don't cross, we'll get the same thing, because these edges are just these 2, these edges are just these 3. So we've got 180 degrees in that one, 180 degrees in that triangle, 180 degrees in that triangle, so on and so forth. And in this heptagon there are 1, 2, 3, 4, 5 triangles. So it's 5 times 180 degrees, which I happen to know is 900 degrees. So that is a way you can always work it out. Now there is a shortcut. We can use this as a rule. So if we think about the number of edges and then the number of triangles when we split it up, and then the total. So we had a triangle, a quadrilateral, a pentagon, we missed the hexagon, we had a heptagon. 3 edges is a triangle. There's 1 triangle. 4 edges, we can cut that across there and get 2 triangles only. It's off the screen. Get 2 triangles only. The pentagon we got 3, which is over here. And the heptagon we got 5 over here. Now 1, 2, 3 blank 5. Hopefully you're seeing that as 4. You can check by drawing a hexagon if you like. And the question is, what can I do that turns 3 into 1, that also turns 4 into 2, that also turns 5 into 3, And you should see that's taking away 2. So if we now do something ridiculous like 115 gone, how many triangles will that have? Well, it will have 130. And then how do these triangles link to the total of all the angles in the total turn? Well, that's 1 times 180 degrees, that's 2 times 180 degrees, that's 3 times 180 degrees, so on and so forth. So this will go up in 180 degrees each time. You do not need to memorise the total in a pentagon and heptagon because you can use this multiplication or you can use this diagram. The final thing to mention is a special case of polygons which are regular polygons. And regular polygons, probably write that clearer, shouldn't I? Regular polygons have got equal edges and equal angles. So in a pentagon, the total is 540 degrees, but if they are all equal, it would be 540 shared equally among the 5 corners, the 5 vertices, which gets you 108 degrees at each and every vertex. So we can now find the total for any polygon, and we can use that to find out what's missing by making it up to the correct total. I hope that helps.